Are you struggling with enemies overlapping and stacking on top of each other? Or are they getting stuck on obstacles and have this weird jittery movement? Don't worry, in this video I will show you how to fix all of these issues. The first thing you'll want to do is import the 2D pathfinding enemy AI for Unity asset into your project. Once you import the asset, you should be able to see a folder called IndieDevs, and under that folder is another folder that contains the actual asset. I have prepared a demo scene with 3 game objects. The first game object is the main camera with a standard camera component. Then we have a grid object which contains 2 children. The first child is a tile map for the ground, and the other is a tile map for all the objects that represent our obstacles. This tile map also has a collider attached to it. Finally, we have a player which contains several standard components, as well as a player movement chase script, which is provided with the asset, and this script allows you to move the player around the world, and it also animates the player. Finally, the player has a single child, which is called the target, and we'll get to this game object a little bit later in the video. Now let's set up our pathfinding algorithm. Firstly, let's create a new game object. We can call this A star. Let's reset the transform, and we can add a new component called A star grid. Once you add this component, 2 more components are added, but you don't have to worry too much about this because there are no parameters to be set here. Now let's set up grid properties of our A star grid. First thing you'll want to do is you'll want to make sure that the show gizmos is set to true, and also that this icon is blue. So basically the gizmos is turned on in your scene view. If that's true, we can go ahead and set the grid properties of our A star grid to match perfectly with the tile map. So first of all, let's set the cell size to 1, and then we can set the width to something like 18. As you can see now, it's perfectly matching. And then we can set the height to something like 10. As you can see, the A star grid is a little bit lower than the tile map, so we can go ahead and set the Y grid center to be 1, and now the A star grid and the grid objects are perfectly matching. Next, let's set up obstacle properties. The first property is the obstacle layer. However, we don't have such a layer so far, so what we can do is we can come here and click on add layer, and now we can create new layer called obstacle. Then we can go to A star game object and select the obstacle as the obstacle layer. Another thing we'll want to do is we'll want to go to the grid game object, and here, if you recall, we have a game object that represents all of our obstacles, and what we want to do is set the layer to be the obstacle as well. Now let's go back to A star one more time, and the last parameter that we have here is the detection diameter. Now the detection diameter tells you how sensitive the algorithm is to detecting obstacles. The higher this value is, the more sensitive the algorithm will be to detecting obstacles. So I will leave this as it is, basically default value 1, but if you want to, you can play around with this and you will see what works for you best. Now the last thing we'll want to do is click this scan button, and if you click this, you should be able to see that all of your obstacles were properly marked as obstacles, and all of the walkable area should be marked green, which is the walkable. Finally, let's add to our scene enemies that will chase the player. So let's go to IndieDevs, do the pathfinding, example, prefabs, and here we have a prefab for the enemy. So let's just drag and drop the enemy into our scene. And the enemy has very similar components as the player has, except the rigid body is set to kinematic. It has 2 scripts. AI movement script gives you a function that you can call, and the function returns you the final direction that the enemy should move to. And there are also a couple of properties that you can set here. The first property is the next waypoint distance. The next waypoint distance is a minimum distance from the current waypoint required to move to the next waypoint. If that sounds confusing, don't worry, I will explain this. It's a very simple concept. What this means is that whenever the enemy calculates the shortest path using A star, so let's say that right now the enemy will have such a path to the target, so it'll go down, then to the right, and then up. And so basically whenever the enemy should change its direction, so for example here it should go from going down to going right, we call this place a waypoint. So here we have 0 waypoint, and here we have 1 waypoint. So basically we are indexing the waypoints. So here's the 0th, then the first, and then the last one is the actual target. And so what the next waypoint distance is that whenever the distance between the enemy and the current waypoint is less than 0.5 or at least 0.5, it will basically start chasing the next waypoint. So it will change the direction and it will go to the next waypoint. I would recommend setting this to default value at first, and then if something is not working quite right, you can play around with this value, but yeah, just try it out. Then we have a few parameters for smoothing. The first one is direction update delay, which is a little delay between each calculation of the shortest path. This delay allows you to get rid of the jittering. So that's the first parameter, and then we have smoothing, which allows you to smoothly transition whenever the enemy is changing direction. Now, one thing to note here is that I wouldn't recommend setting these values to like higher values, something like bigger than 0.1 or 0.2, because then the algorithm could break, so the delay could become so big that the enemy could potentially start walking through the obstacles, and it could have some weird behavior. So feel free to play around with these, just make sure that the values are not too big. Next, let's set the target in the enemy movement chase script. The target will be the child game object of the player called the target. Now, the reason we don't use the player game object itself is very simple. Let me just show you the player game object. So if I zoom in, you should be able to see this little blue point. This little blue point tells you the position of the player. Now, the reason this is important is because if you take even closer look, you should be able to see that this blue point is outside the boundaries of this circle collider. Now, what that means is that if we used this blue point as our target, then whenever the player was, if the player was walking right next to some obstacle, what could potentially happen is that this position would be actually within the obstacle node. And so the enemy can't really get to an obstacle. So what would happen then is that the enemy would actually go to the latest position where the player was seen outside the obstacle nodes, and we don't actually want that. What we want to do is we don't really want to allow the player to go or to walk within the obstacle nodes. So what we do to fix this is we basically create another child game object, which is actually like almost in the center of the player. However, it is also within the boundaries of the collider. So if you take a look again, this is the point we use to calculate the position, and as you can see, this point is within the boundaries. So this is the reason why we use this child game object called target, and we set it here as the target of our enemy. Now let's expand enemy game object. The first child is the steering behavior manager. Now this has a single property called number of rays. This is a number of rays that will be used for context-based steering behavior. The higher the number is, the better the accuracy of the algorithm at the cost of performance. So the really default values are 8 or 16. These are the recommended values. However, feel free to play around with these and you will see what works best for your use case. If we expand a steering behavior manager game object, we have a couple more game objects here. Each game object represents a single part of the context-based steering behavior. So what we'll do is we'll set up all the parameters required for each individual behavior. Now the first behavior is obstacle avoidance behavior, and as the name suggests, this behavior allows the enemy to avoid obstacles. Now the first parameter is the obstacle layer, so let's set this to obstacle. Then we have radius, which is the radius of a circle used to detect surrounding obstacles. Now I will leave this at 1. Then we have a sensitivity parameter, which tells you how sensitive the enemy is to surrounding obstacles. So basically, the higher this value is, the more strictly the enemy will avoid these obstacles. Then the last parameter is the area of sight with a corresponding alignment. And now this is basically a subcircle that is taken into consideration for the detection of the obstacles, and basically all the obstacles that are within the direction of these subcircle are taken into consideration when calculating the final direction. So you can play around it with this. It's basically an area of sight for the enemy when it detects obstacles. So this is the obstacle avoidance. Now let's move on to the enemy avoidance script. And here the first parameter is the enemy. Now the reason we use the enemy here, which basically this enemy property is the enemy itself. The reason we do this is we don't want the enemy to avoid itself. So remember, this script makes sure that the enemies are not overlapping. Then we have the enemy layer, which currently we don't have such a layer. So let's go up here and we can create a new layer. We can call this enemy. Now let's return to the enemy, and what we want to do is set the layer of the enemy to be the enemy. And we also want to set the children as well. Okay, so let's return back to enemy avoidance, and we can set the enemy layer to be enemy. Okay, then the radius is similar to obstacle avoidance radius. So it's the radius of a circle used to detect surrounding enemies. Then sensitivity is how strictly the enemy will avoid other enemies. Now the reason you don't want to set this always to the highest value is because if you have an environment, for example, like this, where the vulnerable areas are quite tight, and let's just imagine that there were like hundreds of these enemies. What could potentially happen is if the enemy wants to avoid obstacles and enemies as well, some of the enemies could potentially make other enemies stuck. So what you could do to make sure that you find always the correct values here is that you set the values and you make a bunch of enemies and you basically try it out, and if they are not getting stuck, then you are pretty much good to go, and the values are are good for the current environment. So yeah, that's about sensitivity. Then we have area of sight and the alignment, which similarly to obstacle avoidance tells you which directions are taken into consideration when calculating the final direction. Finally, we have a seek behavior here, which has a single property called area of sight. Now, this is a subcircle that tells you what directions the enemy could potentially take to get to the target. So the bigger this area is, the more directions the enemy could potentially take. However, I will leave this at 0. And these are basically all the parameters that you need to set here. So what I will do now is I will duplicate a bunch of enemies here now, and I'll just show you how this works. Now all these enemies will just chase the player, and let's see if they are not getting stuck and if everything is working fine. So I will make sure that it is maximized. I will set this to 16 to 9, and now let's see how this works. Okay, so as you can see, all of these enemies are chasing me. Even if I go like here, and they pretty much never overlap, and they don't get stuck even in these tight areas, even though there are quite a few, there's quite a few of them. So yeah, if I just stop, then they will get to me, and yeah. So this is how it works. Okay, so that's it for this video. I hope that it helped you set up the system in your own environment and with your own enemies. If you have some questions, feel free to leave them in the comments, or you can also join our Discord channel. So with that said, I hope you have a great day, and I will see you in another tutorial.